Okay, so we're going to be graphing derivatives of graphs today. So let's first consider a graph so we can take the derivative. So let's make the x and y axis, and we're going to have an off-center parabola, so that's been shifted to the right and down. So this is f of x. So taking the derivative is taking the tangent at any point on the line. So all we need to really consider is the gradient at each point. So we can see that the slope along here is negative all the way down, and it stops becoming negative at this point here where it's 0. And then from that point we've got a gradient of a positive value. So that helps us. We can draw a dotted line through here, and we can have another axis which is our derivative axis. Oh, that was a wonky line. Anyway, so let's draw a dotted line down here. When the gradient is 0, we have an x-intercept. So that's the first thing we put on our derivative graph. So this is going to be f dash of x. When the gradient is positive, it is above the x-axis, and when the gradient is negative, it's below the x-axis. So we know it's going to be graphed like a straight line, like so. Okay, so now we can do a harder question. Well, actually, sorry. Let's have the derivative and the normal graph on top of each other. So we'll have x and y. We'll have x and y. So let's take the derivative of this. So going along the line, we've got a negative gradient, and we've got 0. Positive, and then we got 0 again, and then we got negative. So we can draw dotted lines again. So there's an intercept here, and an intercept here. So if it's above the x-axis, because it's got a positive gradient, that means it needs to bell somewhere, so that means there's a maximum at some point. So it's going up and then down, so it can have two intercepts. So here it's going up and then down, not necessarily on the y-axis. It doesn't have to bell on the y-axis, it could be at any point. And here we've got a negative gradient, so it means it's below the x-axis from this point onwards. And this is below the x-axis from this point onwards because it's got a negative gradient, so it goes like so. So it's an upside down parabola. So this is f dash of x, and this is f of x. And then from that we can even draw the gradient, the derivative graph again. So we could do f double dash of x. So here we've got positives, 0, negatives. So yet again the 0 point isn't exactly on the y-axis. That wasn't specified. You would really have to know what these points are to see whether that turning point is at the middle. So say this was -2 and that was 2. The turning point is on the y-axis. But say this was -2.5 and 2. It's not going to be on the y-axis, this point here. So let's just say for our sake it's slightly off center, which means the intercept is actually at this point, not at the 0, 0 point. So from this point onwards, it's a negative gradient, which means it's below the x-axis. So we're down here. And from that point onwards to that way, it's above the x-axis because we've got a positive gradient. Like so. And then you can even take the gradient of this again. So here we've got a negative gradient the entire time. So that means we've got a line that's actually below the x-axis. Let's just draw it to the side here. And we've got a constant gradient, so it'll actually just be a straight line at some point. which is determined by the gradient of this line. So that's the introduction to graphing derivatives. I'll probably post another video on slightly harder ones and what happens when you've got a sharp turn. Graphing a derivative function like this would be a different situation because you could take any gradient at that point because it's a point. Okay, see you next time.